So in the last video, I tried to replicate the stupidity of almost intentionally exposing your private user data that was supposed to be in a private bucket. And it felt great to actually reinforce my belief that the cloud is relatively secure to build in, and also kind of strengthen my ego, because however stupid things that I've done, at least I'm not stupid as the guy who exposed his core private user data. But I didn't really contribute to the solution. I only talked about how it's hard to actually build insecure applications in the cloud. So in this video, I thought of discussing those points, how to actually build secure cloud applications, how to put safeguards in, and also discuss some of the key principles, you could also say first principles of security when it comes to developing cloud solutions. So before I go into the details, it has been a couple of months since I last put the video out. I know this, but from now on, I'll try to keep a more regular schedule for the videos that I'll do. If you're new to the channel, welcome. I am a cloud architect by trade, and I do videos on cloud software engineering and related areas. If you think that's going to be helpful, please consider subscribing and also like the video if you haven't already. Let's get back to the video. So I'm going to consider a typical web application that will be deployed on the cloud, and also I'm going to use AWS as the cloud provider, but just keep in mind that being secure and developing secure application is not just about developing a web application on AWS. It can be any type of application, it can be any type of cloud provider. As long as you're following these principles, you can be secure almost anywhere. I think that being secure is cloud agnostic. It's also programming language agnostic, although you could argue that something like Rust could actually prevent you from making a certain class of mistakes, but stick to the point with me here. I'm trying to build some general principles that you can use for your everyday software development projects. The points that I'm going to talk about are going to be high level. I'm not going to talk about any specific code. So if you're a junior software engineer, or if you're someone who's new to the cloud, this might feel a little bit boring, but do stick around, because these principles can actually help you develop your career, develop your competencies as a software engineer, actually building good software products, and do that with security in mind. So I'm going to talk about 5 basic security principles: role-based access control, least privilege principle, defense in depth, segmented path to production, and also data classification and separation. And I'm also going to talk about a couple of different practices that you can apply so that you can start applying these principles to software design and also software development. These principles and practices alone is not going to make your application 100% secure. That's not what I'm claiming, but together they will build almost 80 or maybe more than 80% of the security requirements of your application, depending on your business case. So let's talk about RBAC and least privilege principle together. I picked these together because in my mind, these two can't really be effective without each other. So without RBAC, least privilege principle won't really make sense. And without least privilege principle, RBAC will not be effective. So RBAC, or role-based access control, basically means defining different levels of roles for different types of personas or actors in your software product, and then assigning different levels of permissions to those users. This might feel fairly straightforward, and trust me, it is. It's just people will actually start defining different roles, but they will not assign different permissions, especially as the software project goes through its typical life cycle. And I'm also not going to go into the whole RBAC versus ABAC debate. ABAC here means attribute-based access control. For most of the business requirements, RBAC will probably be the case to go on. Attribute-based access control, or ABAC, will probably be helpful for specific use cases. And if you don't have that specific use case, then it might probably not make sense to go with ABAC. It's probably simpler and easier to go with RBAC for your software product. And also, when I mean different levels of actors, I also mean different types of actors that would interact with your deployment environment. So that would also mean different types of users who would be interacting with your cloud environment. So this could be developers, DevOps engineers, administrators, or just security auditors who might be interested in just looking for certain types of evidence. So on one side, you have the software product that would have its own different levels of roles. For your end users, you'd be looking at different users based on what your software product is. So for an example, there could be users who would be able to manage multiple tenants in your software product. There'd be users who would be able to manage resources inside their own tenant, and then there'd be users who might have just read-only view into their own tenant. That's just an example use case. There could be more granular levels of access based on the business requirements. It's really easy to build RBAC capability in your software product using existing libraries or frameworks. So there are different libraries and frameworks depending on the programming language you're using for your product. So it's really easy to start building basic capabilities on top of those libraries and frameworks. When it comes to the other side of the equation, you could start defining typical types of users who would interact with your cloud deployment. There could be developers, there could be DevOps engineers. So for an example, in AWS, there are built-in permission policies called job roles that you can start assigning to these different types of users depending on the type of work that they would do in your cloud environment. So these job roles can be developer, DevOps engineer, power user, and all of those permission policies, and they are a really good place to start with if you don't have a good idea about what your users would be doing specifically in your accounts. The closely related principle to this is least privilege principle. So I just talked about job roles, and yes, they are a good point to start with, but you should really start looking at bringing down the level of permission that you assign to these different users to the bare minimum, so that you'd not be breaking their workflows, you'd not be blocking them from doing their job, but you would also not be assigning more permissions than needed. So that's exactly what least privilege means. You are assigning the bare minimum, the least amount of permissions needed for a user to get their job done. For an example, in AWS, this is really easy to do. You can use a tool called IAM Access Analyzer, where you can start analyzing which permissions have not been used by a user or a given role during a certain time period. So you can start identifying which permissions are not actually used, not actually required for a user to get their job done. And on the other hand, you can also start setting up what are called permission boundaries, which will make sure that in the future you will not assign more permissions than needed for a given role or a given user. So the point that I'm trying to get to here is all the capabilities that you need to implement least privilege principle and RBAC are built into AWS and any other cloud service as well, and it's just a matter of going out there and finding them if you start thinking along these lines of first principles of security. So the next principle I'm going to talk about is called defense in depth. I really like that name. If I'm not mistaken, that comes from military strategy usage, where you'd have multiple lines of defense. If you're trying to defend a certain part of your battle line, a certain area from an expected enemy attack. So the idea there is that you'd have multiple lines, and if the first line fails by any chance, you'd have a secondary line to fall back to and mount another defense from there. So if that line fails, then there's another line. The deeper this defense line goes, the more confident you can be of resisting the enemy attack. The same goes for defending a cloud application. It's not enough to have use authentication if you haven't blocked off the traffic to your database at the network layer. And it's not going to be enough to block traffic at the network layer if you don't have least privilege permissions assigned to whoever's accessing the database, whoever's accessing the data bucket resources. And it's not enough to have least privilege permissions if your use authentication strategy is just username and password without multi-factor authentication. The idea here is that if it takes the failure of a single security control for your application to be completely compromised, then your strategy is not really defense, it's based on luck. If you're still not convinced, ask the French about the Maginot Line during the Second World War. I'm pretty sure I'm pronouncing that wrong, but I never get the French words right. But apparently they had a single line of defense against the Germans, and the Germans just walked around the line, and the whole French army found themselves at a place where they could not defend themselves, so they had to surrender. Of course, history is a lot more complex than that, but let me just use a single example to drive a point home. Why is this the second item in my list? Because I've heard too many times people justifying why they don't really need IP level restrictions because there's use authentication anyways, or why they don't need use authentication because there's IP level restrictions in place. In truth, those designs really needed both of those security controls, because if one failed, the other one would be able to mount the next level of defense. So this next principle of having segmented path to production, I've seen less and less of violations of these principles in the wild in 2025 especially. Most projects seem to know that they need to have separate instances of development, test and production environments. And for example, in AWS, this usually means you'd have different accounts, different VPCs, and different types of rules defining what can be extracted out from these environments. So in my view, that part of the principle is really established in the current software development industry, especially with DevOps and CI/CD practices being applied across the board, with more and more people getting used to having multiple environments and separation between those environments. But what I find more frequently is that even though these projects would have multiple environments, they would start giving for example, administrator access to developers to all of these environments, especially at the early stages of the project. That actually makes sense if you're trying to iterate quickly, especially in those early stages, because you don't really want to block your developers from being able to push out changes more frequently, more quickly. But on the other hand, that practice could come back and bite you in a place that you don't really want, because as you progress through your software lifecycle, especially after going live, if you still keep administrator privileges to the production environment, if you still give out those administrator privileges to all users, you're going to soon find that you have a huge security issue in your environment. One, if people have administrator privileges, they're going to start making manual changes in the production environment. So you're going to lose that advantage of having multiple environments, being able to control how changes are rolled into production. And also, if one of those accounts get compromised, then the attacker will have full permissions into the production environment. So if the only line of defense you have in this scenario is just politely reminding people not to make manual changes on the production environment in those daily stand-ups, then you don't really have a line of defense there, because you can't just depend on people doing the right thing. You can only rely on policies that would not enable people to do the wrong thing. If you keep giving out administrative privileges to production accounts, then people are going to keep using those privileges. Okay, so the fifth principle that I want to talk about is data classification and separation. Most of the large-scale projects actually tackle this problem of data classification early in the project. This is one of the key considerations you'd have if you're designing an architecture for a large-scale project. But most smaller projects don't really consider this aspect of the software lifecycle, because data is typically produced after you go live, during your business as usual period. You need to be able to define different classes for the different types of data your application will produce, and you need to be able to define how sensitive those data classes are so you can apply specific security controls. If you don't have this classification, then your security controls don't really have a background, a basis to be applied, and there's really no justification against why a certain bucket should be private while the other bucket is public. In practice, this is about classifying the personally identifiable information that you'd probably ask from the users so that you can apply the highest level of security to wherever that data is stored. So things like encryption at rest, encryption in transit, least privilege principle, and all of those details. So if you have data that is classified as PII or classified as sensitive, that should be applied the highest level of security, then you have that basis on justifying why a certain Firebase bucket should not be made public. On the other hand, the access logs a load balancer would produce, that might not be that sensitive, but you would still need to keep them inside. So it could be just private data, but you don't have to apply a huge level of security. You can have those logs available for maybe all of the internal users to read. And finally, that email of shame that you would send out when you actually get compromised and having all of your private data leaked, that email is probably going to be classified as public, and you don't really need to implement any security on sending out that email. A real world example on how this data classification could be useful is in AWS you could have different KMS keys for different types of classes and incorporate tagging and config rules, so that if one of the S3 buckets that you have tagged as sensitive or private is not really encrypted with the correct KMS key, then you could have lights go off in your dashboards. You could have an incident response process kicked off to remediate that situation. So there I talked about 5 basic principles, and they are relatively easy to start applying for a given software product. But the real challenge is not going to be actually applying them, but keeping on applying them throughout the software development lifecycle. You can start with least privilege principle based permissions given to your users, but after a few months you get frustrated and start handing out administrator access again to every user. then you have really failed on applying least privilege principle. So it's not enough to just be aware of these principles. You should also be aware of how to apply them effectively throughout the entire life cycle. So you can use these 3 practices that I'm going to talk about next to effectively apply these principles across the entire software product throughout its life cycle. Like the principles that I talked about, these practices are going to be more effective if they are applied together. Just applying 1 or 2 will not probably be as effective as applying all of them together. So the first practice that I want to talk about here is config as code, or what I like to call this is everything possible as code. So if in 2025 you don't know about infrastructure as code, then I don't know why you don't. You should probably learn and understand what that is, especially if you're in the software industry. I don't think it's going to be helpful if you're in baking or cooking. But in any case, infrastructure as code is a good example for what I'm going after here. Having this configuration as code is going to give you 2 key benefits in the software development practice. One is having a reviewable, traceable artifact that you can apply on a given environment, so that when changes are applied, you can review them, hold them until they are good enough to be applied. And also you have a trace of changes and why those changes are done for a given environment or a given policy. The second key benefit is you'd be able to control how those changes are rolled out into an environment. So for an example, you could have an approval process before a certain change is merged into a branch and then run on the production environment. So infrastructure as code, for example, Terraform, CloudFormation, Pulumi, OpenTofu, whatever that you're comfortable with, start using them right away. Start using them from the beginning of the project. There are multiple templates, multiple libraries of modules that you can use to start building a really basic and useful cloud environment with writing minimal code at the moment. And also there are other areas like policy as code. If you find yourself in an environment where policies are being applied on how things are done, so for an example, open policy agent, you can control how changes are run on those policies, how changes are approved. You could have different roles approving the changes into those policies. So for an example, you could have a mandatory security team approval before a certain PR is merged into the policy as code repository. So all of these are available tools that have really small barriers to entry in the current environment. So start using them. It beats having to go through months old or even years old event logs just to find out why Sean from sales or somewhere else wanted a certain bucket made public. So the other practice that I want to talk about is secure secrets management. It's really sad to see how many people still commit secrets into Git in plain text in 2025. There's really no excuse today on committing sensitive details to Git, especially with things that are out there on detecting high entropy strings in the source code before you actually make a commit. You could have various different sensitive details that you need to use in a given component. It could be API tokens, it could be credentials, it could be passwords, connection strings, anything that if exposed could be really bad for your software product. What I've seen happen is that people will start iterating by just pasting in credentials into the software code, and they will just forget that they have added a credential into the source code, and they will make a commit and push. But on the other hand, it's really not that hard to write a piece of code that retrieves a given secret from the secrets management service in the cloud environment that you're operating on. So for an example, in AWS, it's really easy to create an AWS secret for storing the API tokens and then retrieve those tokens during runtime from, let's say, EC2 or Lambda functions with just a couple of lines of code. It only takes 2 or 3 lines to actually retrieve a secret from AWS Secrets Manager using Boto 3 or whatever language library you're using. You end up with 5 or 6 lines of code that will make your life easier when it comes to not making carrier limiting moves. Again, this doesn't have to be AWS. If you're operating in Azure, there's Azure Key Vault. There's something similar in GCP that I can't remember. But what I'm saying is, if you keep committing sensitive details to Git, then honestly, someone should start having a word with you about your career. If you're writing software in the cloud, you should really know about secrets management. So the next practice that I want to get into is having some kind of managed observability for your entire stack. Usually observability kind of translates into getting logs, traces and metrics out of your software product. And while that's true, it should also extend to the cloud platform that you're operating on. The basis for this is the fact that you can't really improve what you're not measuring. If you don't really know what's happening in your cloud environment, you can't really react to them. So for an example, you might need to get alerted if someone is changing users, changing permissions out of business hours in your time zone. So you should be able to get logs for those events. You should be able to get alerts when those logs are detected. On the other hand, why I specifically mentioned a managed observability solution is that an observability stack itself could be a complex software product. So just implementing observability itself could be a headache if that becomes another product stack that you need to worry about. On this aspect, operating in the cloud is the best place to be because you have a lot of built-in services and solutions that you can use without having to worry about the operational aspect of that stack. So for an example, in AWS, if you want logs, you can use CloudWatch logs. You can use X-Ray for traces, and you can use CloudWatch for events and metrics and alarms. And also for the AWS control plane events, you can use CloudTrail. So that's going to be an immutable audit trail for everything that happens on your cloud environment. You can also log data plane events, but I'm more concerned about what's actually being done at the control plane. So if someone's changing permissions, if someone's deleting resources, then you can start building alerts for those type of events and start security incidents almost immediately when those events happen in your system. So observability and being able to enable that observability with minimum possibility. So that's what the cloud brings to you, and just enabling those things in your environment is going to help you measure how effective you are when it comes to applying those security principles, and also keep measuring that effectiveness as you progress through your software lifecycle. Right, so those are the principles and practices that I wanted to talk about. And of course, these are not going to make your application 100% secure. There's obviously a lot more details, a lot more complexity involved when it comes to covering your entire risk registry. But starting from this principle will take you through to that 80% mark that you are looking for most of the applications in the cloud. And to be honest, these principles and practices don't really change depending on the business requirement for the software product. Even if you're building critical components for some obscure business requirement, or if you're building a typical web application, these principles will be the basis for your security posture. What I've noticed typically is that people make bad decisions on the cloud when it comes to security, mostly because they don't know what services are available in the cloud, what services they can immediately start using without a lot of effort involved. So I hope by talking about these principles, I've kind of exposed that side of the cloud, how easy it is to start building secure applications on the cloud. It doesn't matter which cloud you're in, but for most of the typical modern web applications, being in the cloud will enable a lot more capabilities than hosting your application in a VPS or somewhere that doesn't really provide these high-level services. So I hope this was useful. If you have any personal practices that you incorporate in your day-to-day software lifecycle, then do let me know in the comments. Please like the video if you find this helpful. But that's it. That's it for me. Thank you so much for watching. I'll see you in the next video. But most small scale projects smaller projects actually